Good morning students. In the last class we have started a concept as a stationary waves or a standing waves, and in this class I am continuing the same concept, but theoretically we have studied in the last class about stationary waves. In this class we need to study the mathematical representation and the equation of this standing wave or stationary wave. Once again I would like to tell you what do you mean by stationary waves. The stationary waves, when they are forming, when to a progressive wave moving in opposite direction, when two identical progressive waves or a traveling waves, they have to move in a opposite direction. When those two waves they combined or superposed, then the resultant wave pattern we are going to call it as a stationary wave or a standing wave. Two identical waves, identical in the sense, first wave, its frequency, its velocity, its amplitude, everything that is same as the another traveling wave. Frequency same for both the waves, and velocity same, and amplitude same. Each and every quantity is same for both the waves, in the sense those waves we are going to call it as identical waves. ಎರಡು identical wave merge ಆದಾಗ, that what you are observing, that pattern we are going to call it as standing waves or stationary waves. The first wave moving in positive x direction, the second wave moving in negative x direction, and this is first wave, this is second wave, both are in opposite direction. And for first wave I am taking a wave equation. For first wave I am taking a wave equation, that is y1 is equal to a sine of omega t minus of kx. This is a wave equation for first wave. Let us take it as a equation number 1. And what is y1? The y1 is nothing but that is a displacement produced by this first wave moving in positive x direction, and the y1 is the displacement produced by the first wave. That what we need to find out by using this equation. This is a wave equation for first traveling wave and second wave, and consider for second traveling wave, or a progressive wave. For second traveling wave or a progressive wave, the displacement equation is y2 is equal to a sine of omega t plus kx plus pi. I am taking one extra term. Let us take it as a equation number 2. And here first wave I have taken the minus sign here. The minus sign indicating that the wave is moving in a positive x direction. For second wave, this is the equation for second wave. For second wave I have taken, instead of minus I have taken here plus sign. What is the representation of plus sign? This second wave is moving opposite to that first wave. And one more extra term I have taken. What is pi? Pi indicating, is there any phase difference between first wave and second wave? ಎರಡು ವೇವ್ದ ನಡುಕ ಫೇಸ್ ಡಿಫರೆನ್ಸ್ ಏನಾರ ಐತೆನಾ ಅಂತೇಳಿ ಯಾವ ಟರ್ಮನ್ನು ಯೂಸ್ ಮಾಡ್ಕೊಂಡು ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ಬೋದಾ? ದಟ್ ಈಸ್ ಪೈ. ದಿಸ್ ಇಸ್ ಇಕ್ವೇಷನ್ ಫಾರ್ ಫಸ್ಟ್ ವೇವ್, ದಿಸ್ ಇಸ್ ಇಕ್ವೇಷನ್ ಫಾರ್ ಸೆಕೆಂಡ್ ವೇವ್. ಹಿಯರ್ ಮೈನಸ್ ಸೈನ್ ಇಂಡಿಕೇಟಿಂಗ್ first wave moving in positive x direction, and here plus sign indicating, it means that the second wave is moving exactly opposite to that of the first wave. And I have taken extra term, that is pi, indicating, is there any phase difference between first and second wave? That can be indicated by using this term. And here, before going to it as a equation number 2, let us check up, is there any phase difference between those two? Yes. And how we can check up that one? Let us consider first wave and second wave. I am going to merge now. Let us take, this is the first wave. This is the first wave I am taking now. This is the first wave, and second wave I am taking here. Second wave with a dotted line. This is the second wave. Both the waves they are merged. This is the second wave. This is the second wave. This is first wave moving in positive x direction, and this dotted wave is a second wave moving in negative x direction, means in this direction, and both they have merged. This is plus a amplitude and its second wave amplitude is minus a. This is plus a, its amplitude is minus a, its amplitude is plus a, and this is minus a, this is plus a, and this is minus a. This is a first wave and second wave, they merged. This wave is called as a resultant wave. Eradu wave combine adaga siguvanta wave ಗೆ ಏನಂತೀವ resultant wave, and this wave is called as a stationary wave or a standing wave. This is first traveling wave, second traveling wave, both they have merged. That wave pattern is called as a stationary wave or a standing wave. And you have to check up, is there any phase difference between first wave and second wave? Yes, of course phase difference is there. Let us consider the second wave. I am taking like this also, this term, this is second wave. For second wave phase difference is 0. For second wave phase difference is pi by 2 here, means 90 degree. For second wave phase difference is 180, means pi radian. At this point phase difference pi is equal to pi 2 minus pi 1. At this point the phase difference for second wave, that is 180, means pi radian, minus at this point the phase difference for first wave, that is 0, means phase difference is equal to pi radian. Pi radian means the 180 degree angle. ಎರಡು ವೇವ್ ನಡಕ ಪೊಸಿಷನ್ ಒಳಗಡೆ phase difference ಎಷ್ಟದ, that is 180 degree. It means that let us take second wave, angle is 0, second wave here angle is 90 degree, means pi by 2. Second wave the angle is 180 degree, means pi. At this point what is the phase angle for second wave? 180. At this point what is the phase angle for first wave? 0 degree. Pi minus 0 means pi radian. It means that 180 degree. ಎರಡು ವೇವ್ ನಡಕ phase difference 180 degree ಅದ. Let us take, I am taking, modifying this equation, y2 is equal to a sin of omega t plus of kx. I am replacing pi as pi radian, because in between those two waves the phase difference is equal to 180 degree. Let us take it as equation number 2. By using this equation the displacement of the first wave can be find out. By using this equation the displacement produced by the second wave can be find out. And how to find out the displacement produced by this stationary wave? That is, first wave second wave merged, then the resultant wave is called as a stationary wave. Its displacement can be find out by using the another equation. Add equation 1, add equation 2. Therefore the displacement for resulting wave, which is the resulting wave? This is stationary wave, is a resulting wave. Progressive added resulting wave is called as a stationary wave. Its displacement, resulting wave means the stationary wave, resulting wave can be given by y is equal to y1 plus y2. y1 means equation for first wave, first traveling wave, a sin of omega t minus of kx, plus y2 is displacement for second traveling wave, that is a sin of omega t plus kx plus pi, plus kx plus pi. Let us take it as a whole bracket like this, and here a is common, take a out, a is common, then sin of omega t minus kx as it is, and this is plus sin of omega t plus of kx plus pi. And here we know very well this is sin c plus sin d is there, and this pi I am writing like this, this is pi. And let us take, this is theta, this term is a theta, this is pi. Sin 180 means here pi is nothing but 180. Sin of 180 plus theta, this is theta, means third quadrant. In third quadrant sin is negative. In third quadrant only tan is positive, remaining all are negative. ASTC means add sugar, ASTC getting, that is, as you know very well, trigonometric ratios. ASTC, add sugar T cups. are all sugar teacups. You know very well this formula. Sine of 180 plus theta, it is nothing but sine 180 plus theta means sine theta. In the third quadrant sine is negative, that's why I am taking it as y is equal to a into sine of omega t minus kx. I am taking it as minus sign because sine 180 plus theta, this is third quadrant. In third quadrant sine is negative. Sine 180 plus theta is sine theta. Theta is nothing but this term. This is theta term. Don't confuse here. I left 180. Sine 180 plus theta. This is whole term is a factor is theta. Sine 180 plus theta third quadrant. Third quadrant ಒಳಗಡೆ sine ಏನ negative. Therefore sine 180 plus theta, that is sine theta. In third quadrant sine is negative. That's why I am taking here sine. And here this is the form. This is sine c. This is the form you know very well. This is sine c minus sine d. Sine d. This is a general formula as you know very well. What is the formula? Sine c minus sine d. That is sine c minus sine d is equal to, use the formula. We know that the formula sine of c minus of sine of d. This is equal to 2 cos c plus d by 2 sine of c minus d by 2. This is a general formula you know very well. This is a formula you know very well. This is a formula, and here this is also sin c minus sin d is there. Sin of c minus sin of d. Apply this formula to here. Therefore this equation become y is equal to a as it is sin of what is c, sin c minus sin d, getting a as it is sin c minus sin d. Apply this one. Therefore that is becomes 2 as it is cos as it is. What is c? C is nothing but omega t minus kx, omega t minus kx, and plus as it is. What is d? D is nothing but omega t plus kx, omega t plus kx whole divided by 2, whole divided by 2, and next sine of c minus d by 2. What is c? This is omega t minus kx, and omega t minus kx minus what is minus as it is. What is the d? Omega t plus kx, omega t plus kx whole divided by 2, and here y is equal to a 2 cos omega t 2 omega t, this one getting cancelled, 2 omega t divided by 2, these two getting cancelled, and again sine of omega t and minus omega t, that is getting cancelled, these two, minus kx minus of kx, that is minus 2 kx divided by 2 getting cancelled. What is the result you are getting? That is, let us take, I am writing this term here, y is equal to 2a cos omega t sine of kx. This is minus kx, this minus I am taking here. Therefore y is equal to minus 2a cos or sin kx cos omega t. This is final equation. This is final equation. This equation is displacement of resultant wave. Displacement of a resultant wave. What is the resultant wave? That is a stationary wave. This one. Displacement of resultant wave. Resultant wave. What is this equation? This is, by using this equation, displacement of the first wave can be find out, first travelling wave. And what is this equation? By using this equation, displacement of second travelling wave can be find out. And what is this equation? By using this equation, displacement of this resultant wave can be find out. Just here, what is this minus sign indicating? The minus sign indicating if is there any phase difference between first wave and second wave, indicating the phase difference between first and second wave is 180 degree, or 5 radian. ಎರಡು ವೇವ್ದ ನಡಕ ಫೇಸ್ ಡಿಫರೆನ್ಸು 180 ಡಿಗ್ರಿ ಇದ್ದಾಗ this minus sign is coming here. The minus sign in the resultant wave equation, that is indicating as if is there any phase difference between first wave and second wave, that is indicated by the sign as negative. If there is a positive sign, this positive sign indicating if there is a phase difference between first wave and second wave, if it is 0 degree, then you are getting a positive sign. And don't confuse here, the minus sign indicating just the minus sign representing that the phase difference between the first wave and second wave is 180 degree. And here this equation can also be write as modifying, that is y is equal to, I am writing 2a sin kx as a cos omega t. We can also write this equation like that. And here what is a is nothing but amplitude of this stationary wave. The amplitude of stationary wave can be find out by using a term as a is nothing but 2a sin kx. Therefore a is equal to 2a sin of kx. This is amplitude. The amplitude, total amplitude of this one can be find out by using this formula. 2a sin kx is indicating total amplitude, and here therefore this term indicating the amplitude 2a sin kx cos omega t, and here amplitude is equal to this term. And here in the stationary wave there are some regions or points are there. Those points we are going to call it as nodes and antinodes. For example, here one point is there. Let us take it as a n. I am indicating this point is an, means antinode. This point is an called antinode, and this point is called as n called node. This point is called as an antinode. This point is called as our antinode. This is called as a node point. This is called as an point. This is called as an point, and this is called as a node point. This is called an, means antinode. This point is called as antinode. We will discuss about what do you mean by node points and antinode point. And you remember this equation. This is the equation for resultant wave. By using this equation, the displacement of this stationary wave can be find out. And next further, in the stationary wave there are some important terms are there. The first term is, that is a node point. What is a node point? Nodes or node points. Node points. What are node points? This is the regions or the points in the stationary wave having a zero displacement. What are node points? These are the regions in the stationary wave. These are the regions or points in the stationary wave having zero displacement or having zero amplitude. Regions are points having zero displacement, or zero amplitude. Zero displacement in the sense amplitude is zero. Amplitude called node points. Called node points. As you know very well, this is a standing wave or a stationary wave, and what is the displacement at this point? That is 0. And what is the displacement at this point? That is 0. As you know very well, this is a 0 point. And what is the displacement at this point? This is 0. And what is the displacement at this point? That is also 0. And what is the displacement at this point? That is also 0. In the stationary wave, these are the points or the regions having a zero displacement. The points which are having zero displacement, those points are called as n. It means that node points. Node point ante yavudಕ್ಕೆ ಅಂತಾರ? ಸ್ಟೇಷನರಿ ವೇವ್ ಒಳಗಡೆ ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ಎಲ್ಲಿ ಝೀರೋ ಇರ್ತದಲ್ಲ ಆ ಪಾಯಿಂಟಿಗೆ ಏನಂತಾರ? ನೋಡ್ ಪಾಯಿಂಟ್ ಅಂತೇಳಿ ಕರೀತಾರ. Those points are called as a node points. And another term is there, that is called as antinodes. What are antinodes? These are the regions are the points in the stationary wave. These are the points in the stationary wave having a maximum displacement. These are the points in the stationary wave having maximum displacement. In the stationary wave having maximum displacement or amplitude. Stationary wave having maximum displacement called as antinodes. Maximum displacement called antinodes. In the diagram we have to see some of the regions here. Here the displacement of the wave is 0. Here the displacement of wave is 0. Here displacement of wave is 0. Here displacement of wave is 0. Here displacement of wave is 0. The regions are the points where the wave is having a 0 displacement. Those points we are going to call it as a node point. And except node points, there are some other regions are there or points are there. Let us take this point or this point. Here the displacement is not 0. This is maximum displacement. Or here this is maximum displacement. Or here the displacement is not 0. I am taking this point. Or here displacement is not 0. Or here displacement is not 0. Here displacement is not 0. Here displacement is not 0. Means these are the points, they are not indicating the 0 displacement. Means at that points the displacement is maximum. Those points we are going to call it as antinodes. Stationary wave ಒಳಗಡೆ ನಿಮಗೆ ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ಯಾವ ಪಾಯಿಂಟ್ ದಾಗ 0 ಸಿಗ್ತದ ಆ ಪಾಯಿಂಟಿಗೆ ಏನಂತ ಕರಿಬೇಕಾ ನೋಡ್ ಪಾಯಿಂಟ್ಸ್. And in the stationary wave where you are getting a maximum displacement, those points we have to call it as antinode point. And now we have to discuss nodes and antinodes with a mathematical representation. And getting you please note down up to this one. And here the displacement is 0, here displacement is 0, here displacement is 0, and here displacement is 0, and these are node points. We have to indicate mathematically node points as well as antinode points. And before going to start the conditions for nodes point and antinode points, let us study this also. Let us consider this as a one wave. Let us consider it as a one wave. Its wavelength is lambda. Its wavelength is lambda. The length of one complete wave is called as a wavelength. And here if you consider just half of the wave, then we are taking it as lambda by 2. As you know very well, half of lambda is, that is lambda by 2. Or if you considering that is a quarter part of the wave, that is lambda by 4. It means here to here this is lambda by 4, and again here to here this is lambda by 4, and again here to here this is lambda by 4, and again here to here this is lambda by 4. Means lambda by 4 plus here to here lambda by 4 plus lambda by 4 plus lambda by 4 plus lambda by 4. If you add lambda by 4 plus lambda by 4 plus lambda by 4 plus lambda by 4, then you are getting one complete wave. Then the length of one complete wave is equal to, that is lambda. Lambda is length of one complete wave. And if you consider half of the wave, its wavelength is lambda by 2. Or if you consider a quarter part of the wave, its wavelength is, that is lambda by 4. Therefore here to here lambda by 4 length of the wave, here to here lambda by 4, again here to here lambda by 4, again here to here lambda by 4. Lambda by 4 plus lambda by 4 plus lambda by 4 plus lambda by 4, that is if you take a LCM you are getting, that is lambda. Lambda by 4 plus lambda by 4 plus lambda by 4, LCM is 4 lambda by 4, 4 getting cancelled, you are getting lambda. This is the length of one complete wave. And now we can study the mathematical representation of node and mathematical representation of antinode. And the mathematical representation of the node, it is indicating 0 displacement, and mathematical representation of antinode indicating, that is maximum displacement. We can study, and here that is a mathematical condition. Okay, next we can study here the nodes indicating the displacement of the points in the stationary wave, that is 0. In the this standing wave, the regions are the points where the displacement is 0, those are called as the nodes. We can indicate mathematically the node points having 0 displacement. Let us take that equation we have discussed, that is y is equal to 2a sine of kx cos omega t. This is a equation of this stationary wave, and this term indicating it as amplitude. This term indicating it as amplitude. And here consider for node points I am discussing now. For node points, consider amplitude of node points. Amplitude of node points that is equal to 2a sine kx, that is equal to 0. For node points, amplitude is always 0. See, this is node point, amplitude is 0. This is node point, amplitude is 0. Node point, amplitude is 0. Node point, amplitude is 0. For all the node points, the amplitude is 0. That's why the amplitude is 0 for all the node points. That's why I have taken this is 0. And here the general equation I am taking, that is, from this equation I am considering a kx as a term. Kx is equal to n phi. This is general equation. N phi. Here n is a constant or integer. N is equal to, it is a 0, it may be 1, it may be 2, it may be 3, so on. And here kx is equal to, substitute n is equal to 0. N is equal to 0 and into pi. This is 0 into pi. You are getting, that is kx is equal to 0. And substitute n is equal to 1. N is equal to 1. Then substitute 1, pi as it is. Then 1 into pi, that is pi, means kx is equal to, you are getting phi now. And third condition, substitute n is equal to 2. N is equal to 2. Then 2 into pi, means kx is equal to, that is 2 pi. And substitute n is equal to 3, then you are getting 3 pi, means kx is equal to, you are getting 3 pi. If you substitute n is 0, then kx is equal to 0. If you substitute n is equal to 1, then kx become pi. If you substitute n is 2, then 2 pi, means you are getting kx is equal to 2 pi, so on you are getting, it is a n pi. Getting? N is equal to 0, kx is equal to 0, n is equal to 1, that is 1 pi. Yes, n is equal to 2, then that is 2 pi. N is equal to 3, that is 3 pi. This is, so on continuously it is going. And here I am talking about node points. For node points, amplitude or displacement is 0. Let us see here, kx is equal to 0, means phase angle is equal to 0. Where is the phase angle? This is 0 degree. 0 degree means what is the displacement here? Displacement is equal to 0, means the displacement 0 in the sense you are going to call it as node point or anti-node point. Yes, it is a node point, because what is the angle? 0 degree. Where is the 0 degree angle? This is 0 degree. At this point, this is node point, the displacement is maximum or 0, the displacement is 0. Then can I call it as node or anti-node? This is node point. Yes, you are getting now. There, if angle is 2 pi, where is 2 pi? 2 pi means this is 0, this is 90 degree, this is 180, this is 270, this is 360, means 2 pi. 2 pi means here displacement is 0. It is node point or anti-node point? Yes, it is a node point. And again go to 3 pi. 3 pi means here to here pi, here to here 2 pi, here to here 3 pi. 3 pi means here displacement is 0, means displacement 0 in the sense, is the point is anti-node or node point? Yes, it is a node point. Getting? 0 degree. Where is 0 degree? Yes, here is 0 degree. What is the angle here? 0 degree. Then displacement, what is the displacement here? 0. Then it is a node or anti-node? Yes, it is a node point. And go to 180 degree. Where is 180 degree? Here 180 degree. Here what is the displacement? 0. 0 displacement in the sense, is it a node point or anti-node point? Again it is a node point. Again go to 3 pi. Where is 3 pi? Here to here pi, here to here 2 pi, here to here 3 pi. Here 3 pi, this is the point. What is the displacement? 0. The 0 displacement in the sense, is it a node or anti-node? This is a node point. Yes, it is a node point. Or in terms of path difference, you can write, what is k? K can be calculated by using the formula 2 pi by lambda. What is k? K is nothing but wave number. Wave number in the sense we are going to call it as k. K can be calculated by using 2 pi by lambda. What is k? K we are going to call it as wave number. Wave number. K can be calculated by using formula 2 pi by lambda. K is nothing but number of waves present in 1 meter of length. Number of waves present in 1 meter of length. Present in 1 meter length is called as wave number. Is called as wave number indicated as K. 1 ಮೀಟರ್ ಅನ್ನು ಲೆಂತ್ ಒಳಗಡೆ ಎಷ್ಟು ಕಂಪ್ಲೀಟ್ ವೇವ್ ಸೆಟಪ್ ಆಗ್ತಾವಲ್ಲ ಆ ವೇವಿಗೆ ಏನಂತಾರ ವೇವ್ ನಂಬರ್ ಅಂತಾರ. ದಟ್ ಈಸ್ ವೇವ್ ನಂಬರ್ that is indicated as K as a letter, and the wave number can be calculated by using the formula as 2 pi divided by lambda. 1 ಮೀಟರ್ ಅನ್ನು ಲೆಂತ್ ಒಳಗಡೆ ಎಷ್ಟು ವೇವ್ ಸಿಗ್ತಾವಲ್ಲ ಆ ವೇವಿಗೆ ಏನಂತಾರ ವೇವ್ ನಂಬರ್ ಅಂತಾರ. and how to find out a number of waves present in 1 meter of length, that is the formula as K is equal to 2 pi by lambda. I have taken the formula of K here. Don't confuse. What is K? Wave number. What is wave number? Number of wave present in 1 meter of length in the medium. Those waves we are going to call it as wave number. And how to find out the wave number? By using the formula as 2 pi by lambda. And I am writing x as it is. X as it is, remaining 0 as it is, 1 pi as it is, 2 pi as it is, 3 pi as it is. This is so on. And if you substitute here, let us take, if you substitute, I want to find out x. X indicating wavelength of wave, or it is the distance covered by the wave. Let us take x. First condition, 2 pi x by lambda is equal to, I am taking 0. Second condition, 2 pi x by lambda, I am taking it is 1 pi. 1 pi. Third condition, 2 pi x by lambda, I am taking it as 2 pi. Fourth condition, 2 pi x by lambda, this is equal to, I am taking it as 3 pi. 2 pi x by lambda is equal to, first time I am taking it is equal to 0. Second, 2 pi x by lambda is equal to, I am taking 1 pi. Third condition, 2 pi x by lambda is equal to 2 pi. And 2 pi x by lambda is equal to 3 pi. And I want to find out what is the value of x. Here what is the value of x? Here 0 into lambda 0, then 0 by 2 pi 0, then x is equal to 0. X is equal to 0. And second, here lambda into pi, that is lambda pi, that is lambda into lambda pi divided by 2 pi. Pi getting cancel, you are getting this is lambda by 2, means x is equal to lambda by 2. And here 2 pi getting cancel, x is equal to lambda. Here x is equal to lambda. Here x is equal to lambda by 2. And here pi getting cancel, and x is equal to 3 lambda by 2. Like that you are getting. Let us take here x as it is. X as it is. Let us take first 2 pi by lambda into x, this is equal to 0. And now lambda into 0, 2 pi x lambda into 0, x is equal to lambda into 0 divided by 2 pi, then x is equal to 0. Means let us take now x is equal to 0. And second, 2 pi x lambda is equal to, I am taking 1 pi. 1 pi getting cancel, and x is equal to lambda by 2. Lambda by 2. Lambda, x is equal to lambda by 2. And third condition, 2 pi x by lambda is equal to 2 pi you can take, means 2 pi get cancel, x is equal to lambda. X is equal to lambda. Again take the same condition, 2 pi x by lambda is equal to, you can take 3 pi, then you are getting 3 pi divided by lambda. That is 3 lambda divided by 2. And let us take this one and check out. These x value indicate antinode or node. You have to find out here. X is equal to 0. Yes, x is equal to 0 means, is it node or antinode? Yes, it is a node point. One thing is clear. And next, x is equal to lambda by 2. Where is lambda by 2? Here to here lambda, here to here lambda, here to here lambda by 2, here to here lambda by 2. Means this point to this point, the length of the wave is lambda by 2. The lambda by 2 means at this point, is it node point or antinode? Yes, again it is a node point. Again go to lambda. Then lambda means where is lambda? Yes, this is lambda. Here to here, this is lambda. Means lambda means is it node point or anti-node point? Again it is a node point. Go to 3 lambda by 2. Where is 3 lambda by 2? Yes, 3 lambda by 2 means this point. Here to here, this is 3 lambda by 2 means this point, again indicating anti-node or node point. Again node point. Getting? This is a mathematical representation in terms of phase angle, in terms of path difference. Both conditions indicating a node point. Here 0 degree, 0 degree, it is a node point. Here 180 degree, 180 degree at this point, again it is a node point. 360 degree means this point, again that is a node point. Again that is 3 pi, where is 3 pi? This is 3 pi, means again it is a node point. Or in terms of x value, the x is nothing but the distance covered by the wave. X is equal to 0, means 0 point, node point. Lambda by 2, where is lambda by 2? Length of the wave lambda by 2, node point. Again lambda, node point. 3 lambda by 2, yes, here to here 3 lambda by 2, again that is a node point. This is amplitude condition of node points. And next we can discuss about, that is for amplitude of antinode. Amplitude of antinodes. Amplitude of antinodes, and this one generally we can write it as, generally x you can write it as n lambda by 2. N lambda by 2. If n is equal to 0, if n is equal to 0, 0 lambda by 2, 0. If n is equal to 1, 1 into lambda by 2, lambda by 2, yes. If n is equal to 2, 2 lambda by 2, 2 to getting cancelled, you are getting lambda. If n is equal to 3, 3 into lambda by 2, 3 lambda by 2, yes, it is satisfying. Generally x can be written as, n lambda by 2. Generally x can be written as n lambda by 2. If n is 0, 0 into lambda, 0, 0 by 2, 0. If n equal to 1, 1 into lambda by 2, lambda by 2. If n is equal to 2, 2 to getting cancelled, remaining is lambda. If n is equal to 3, 3 lambda by 2, yes, 3 lambda by 2, yes, this is a general equation for path difference, and this is for a phase difference. This is phase and this is path. Now I am talking about amplitude of antinode, that is given by the formula as 2a sine of kx is equal to plus or minus 2a, because per antinode this is plus 2a. Per antinode this is plus 2a, because now you can take this like this also, stationary wave. Stationary wave you can take like this also. If the phase difference is equal to 0, then this is plus 2a, this is plus 2a, this is plus 2a, and this is plus 2a. If the phase difference between first wave and second wave is 0 degree, then plus 2a, plus 2a, plus 2a, plus 2a, we can take like this also. Or this is phase difference is 180 degree, here phase difference is 0 degree. From the equation I am taking, that is kx is equal to general formula I am taking 2n plus 1 lambda by 2, n is equal to 0 or 1 or 2 or 3, so on. And here if kx, if n is equal to 1, 0, if n is equal to 0, kx, n is equal to 0, 0 into 2, 0, then 1 into pi by 2, that is pi by 2. And if n is equal to 1, 2 into 1, 2 plus 1, 3, 3 pi by 2, 3 pi by 2. If n is equal to 2, 2 into 2, 4, 4 plus 1, 5, 5 pi by 2, 5 pi by 2. If n is equal to 3, 2 into 3, 6, 6 plus 1, 7, 7 into pi by 2. Or so on, you can write generally 2n plus 1 pi by 2. How come? If n is equal to 0, substitute 0, 2 into 0, 0. What is remaining? 1, 1 into pi by 2, pi by 2. If n equal to 2, 2 into 2, 4 plus 1, 5, 5 pi by 2, 3 pi by 2. If n equal to 2, 2 into 2, 4 plus 1 means 5 pi by 2, so on. This is the general formula. What is pi by 2 here? Pi by 2 means 90 degree. Where is pi by 2? Yes, here is the pi by 2. Pi by 2. Pi by 2 means Is the displacement is 0? The displacement is not 0. Then this point is called as node point or anti-node point. This is anti-node point. Go to next 3 pi by 2. 3 pi by 2 means 270 degree. Where is 270 degree? The 270 degree means this is a 270 degree. This is a 270 degree. 270 degree in the sense this point is called as a node point or anti-node point. Yes, it is anti-node point. Again 5 pi by 2. Yes, where is 5 pi by 2? This is 5 pi by 2. 5 pi by 2 means the displacement is not 0. Displacement not 0 in the sense it is anti-node. Means it is anti-node. 90 degree. Yes, anti-node. 270 degree. Yes, anti-node. This is 270 degree. That is 5 pi by 2. Again where is 5 pi by 2? This is 5 pi by 2. Again anti-node. And this phase difference are this phase angles indicating this is a anti-node point. Again K I am writing 2 pi x by lambda. This is equal to pi by 2, 3 pi by 2, 5 pi by 2, 7 pi by 2, so on. And here find out the value of x. 2 pi by lambda into x is equal to pi by 2, and here pi getting cancelled. Lambda, that is x is equal to lambda by 2 into this 2, that is x is equal to lambda by 4. X is equal to lambda by 4. Once again this is x as it is, pi getting cancelled, and here lambda by 2 cross multiply lambda by 2 and this 2 taken here, then x is equal to lambda by 4. This is lambda by 4. Then x is equal to here lambda by 4, comma you can take 2 pi x by lambda. This is first. Second, 2 pi x by lambda is equal to, we can take this is equal to 3 pi by 2. 3 pi by 2, pi getting cancelled, and here x is equal to cross multiply 3 lambda, this 2 as it is and this 2 taken in the denominator, x is equal to 3 lambda by 4. This is 3 lambda by 4. Next, so on you can take another condition, 2 pi x by lambda is equal to, that is 5 pi by 2, 5 pi by 2, pi getting cancelled, pi getting cancelled, then x is equal to lambda means 5 lambda by 2 and this 2 taken here 2, x is equal to 5 lambda by 4, means this is 5 lambda by 4. Next continue the same, 7 lambda by 4, 9 lambda by 4, means in terms of a odd number, 1 lambda by 4, 1 onwards 3, 3 means 5, 5 goes 7, 7 means 9, 11, 13, it is goes on continuous. Generally I am writing 2n plus 1 into lambda by 4. Here substitute, n is equal to 0, 1, 2, 3, so on, 1, 2, 3, so on. Substitute n is equal to 0 here, 2 into 0, 0, remaining is 1, 1 into lambda by 4, you are getting lambda by 4. And substitute n is equal to 1, 2 into 1, 2 plus 1, 3 means 3 lambda by 4, that is 3 lambda by 4. And substitute n is equal to 2 here, 2 into 2, 4 plus 1, 5, 5 into lambda by 4, 5 lambda by 4. Next substitute 3 here, 2 into 3, that is 6, 6 plus 1, 7, 7 into lambda by 4, 7 into lambda by 4, and this is the general equation. By using this equation you have to substitute respectively n is equal to 0, 1, 2, 3, 4, so on, then you are getting a path difference or a path values like this. If lambda by 4, where is lambda by 4? This is lambda by 4, this is lambda by 4, means lambda by 4 means this point is called as antinode. Point is called as antinode. Next go to 3 lambda by 4. Where is 3 lambda by 4? This is lambda by 4 plus lambda by 4 plus lambda by 4. This is 3 lambda by 4, means this point. This point is node point or antinode. Again that is a antinode point. With respect of these phase angles, all the points you are getting called as antinode points, and with respect of these path difference or path values, that the points you are getting in the stationary wave all are antinode points. And with respect of these angles, and this x values, whatever the points you are getting, those points are called as the node points. And with respect of this phase values and this x values, all the points you are getting called as a antinode points. And you just remember the definition of node and definition of antinode, that is enough. And this is just a general discussion about how to represent a node point by using a phase angle, and how to represent a node point by using, that is distance covered by the wave. The node point and antinode point definition is important. Node is nothing but these are the points in the wave which are having a zero displacement or a zero amplitude, those are called as a node point. And the points in the wave which are having a maximum displacement or a maximum amplitude, those are called as antinode points. If you use these phase angles or these x values, there all the points you are getting as a node points. Or if you use these phase angles or these x values, and all the points you are getting in the wave are called as antinode points. And this is the completion of a stationary wave. In the next class we have discussed about what is the difference between a stationary wave and the next one is a progressive wave.